Good day everyone and welcome to Teacher Mavi's class. So for today's video, we will talk about prime and composite numbers. So just sit back, relax, and enjoy the lesson. So first, we will talk about prime numbers. So prime numbers is a whole number greater than 1 whose only factors are 1 and itself. So a factor is a whole number that can be divided evenly into another number. So the first few prime numbers are 2, 3, 5, 7, 11, 13, 17, 19, 23, and 29. Next, what are composite numbers? So composite numbers are numbers with more than 2 factors. So it is a number that is divisible by a number other than 1 and the number itself. So for example, we have 6. So 6 is a composite number that is divisible by 1, 2, 3, and 6. And this 1, 2, 3, and 6 are what we call the factors of the number 6. So therefore, it is a composite number because 6 has more than 2 factors other than 1 and 6. So how to determine if a number is prime or composite numbers? So first, we have many different ways on how to find how to determine if a number is prime or not. So we have here a factorization method. So the first step, we have to find the factors of the given number and list them, and then check the total number if the factors of that number is more than 2 or not. And step 3, if the number has just 2 factors, then you can conclude that the given number is prime number, and if that number has more than 2 factors, then it is a composite number. So for example, we have here, check if 29 is prime or not. So first, using the factorization method, we have to determine the factors of 29, and we only have 1 and 29. So we have 2 factors, 1 and 29 itself. Therefore, we can conclude that 29 is a prime number by definition. Next, we have here, check if 81 is prime or not. So, using again the factorization method, we have the step 1, list all the factors. So, by getting these factors, we can use the prime factorization method like that. So, there are 5 factors of 81. We have 1, 3, 9, 27, and 81. And therefore, it is a composite numbers. It is a composite number, rather. But what if the number is so large that you cannot use prime factorization because it takes you time to determine large numbers using factorization? So we have clues, hints, and other method on how to determine if large numbers are prime or not. First, if a large number ends with the digits 0, 2, 4, 6, and 8, then it is a composite number, not a prime number. Why? Because it is an even number which is easily divided by 2, or it is divisible by 2. And once it is divisible by 2, then the factors will be more than 2. Therefore, it will be a composite number. Next, if a large number ending with digit 5 or 0, it is not a prime number. Again, it is easily divided by 5. Next, to determine if a large number are prime or not, so we have to add the digits of the large number and then divide it by 3. So if it is exactly divisible by 3, like 3 to 24, like that, without decimals or without fractions, then the large number is not a prime number. So another one, if the result of the first three methods out of the two methods is false, then we take out the square root of the number and then list all the prime numbers below the square root value and divide the given number by all these listed prime numbers below the square root of that number. And if the number is divided by any of the prime numbers less than the square root, then it is not a prime number, otherwise it is a prime. So we have here to further understand on how to determine whether a large number is prime or not. So we have example number 1. Determine whether 2017 is prime or not. So we will use the method, the last method that I've mentioned. We square the number and then we have the square root of 2017 is equal to 44.91, and we rounded it off to the nearest whole number. We have 45. And then the step 2, we list the prime numbers below 45 are these numbers. We have 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, and 43. And then we will divide the number by these numbers, and then if the result is exactly a whole number, then that number is not a prime number. So we will divide 2017 by 2 and so on and so forth, and we did not find a result that is exactly a whole number. Therefore, we can conclude that this number 2017 or 2017 is a prime number. Example number 2, we have to determine whether 1,234,567 is prime or not. So we cannot use factorization method here because the number is too large and we will take time to determine if it is prime or not. So we will use alternative ways, and we will use this method. You add all the digits of the large number and then divide it by 3. So we have to add the digits 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7, and it's equal to 28. And then we divide 28 by 3 and we will have 9.33. So the result, as we can see, the result is not exactly a whole number, and therefore we can conclude that it is a prime number. Okay, so this number, this large number is very it will take time for us to determine this large number using the method of squaring it. Okay, so we will use this method instead of that one. And yes, it is a prime number. So that is all for how to determine if a large number is prime or not. And there's also different ways on how to determine if a large number is prime or not, and we will talk it in my next video. So some facts about prime numbers. So 2 is the smallest prime number, and 2 is the only prime number that is even. Why? Because even numbers greater than 2 are composite numbers because they can easily be divided by 2. And 2 and 3 are the only consecutive prime numbers. And next, except for 0 and 1, a whole number is either a prime number or a composite number. Why? Because 0 is neither prime or composite number, since any number times 0 equals 0, and there are infinite number of factors for a product of 0. So a composite number must have a finite number of factors. And for 1 is not a prime number because 1 has only one factor, only 1, and a composite number has more than two factors, and prime numbers have 2 factors, and it does not satisfy the definition of prime and composite number, so therefore 0 and 1 are not prime numbers or composite numbers. Next, all odd numbers are not prime numbers. For example, we have 21 and 39. So 21 is an odd number, and this is not a prime number because 21 has factors like 7, 3, 1, and 21. Next, we have no prime number greater than 5 ends in a 5. Why? Because if any number greater than 5 ends in a 5, it is divisible by 5 and it will not be a prime number. Hence, it is a composite number. Next, we have the sieve of Eratosthenes is one of the earliest methods of finding prime numbers. So, it is a simple and ancient algorithm used to find the prime numbers up to any given limit, and it is one of the most efficient ways to find small prime numbers. So, it looks like this. Next, prime numbers get rarer as the number gets bigger. And lastly, there is no largest prime number because of the existence of infinity. And I guess that's all for today's video, for today's lesson and discussion. I hope you learned something. Again, this is Teacher Mavi's class, and see you in my next video. Bye!